Okay, we've learned the derivatives of trig functions. Now we're going to talk the derivatives of inverse trig functions. So learning goal, students will be able to find the derivative of functions involving inverse trig expressions. Okay, so this is the deal, is these are they're kind of nasty, but you just have to memorize them. But they're not that bad. There's some patterns here. So take a look at them. All of the co-functions, so you have sine, cosine, tan, cotangent, secant, cosecant, they're pretty much identical except for the cosecant ones are just negative. See? So that's not that big a deal. They all have a 1 on top, and they all have some type of x squared and a 1 on the bottom, usually involving a square root. So very similar, and if you could just remember these three, you have these three because the co-functions are just the opposites, just the negatives. So you do just have to memorize these, but they're really not that bad. They look kind of nasty, but they're not that bad to memorize. So make some flashcards and just get them memorized. So now let's just talk about how to use them. Let's look at this first one. We have y equals the arc cosine of x squared. So how could we do this? Well, there's the formula there. But the problem is that we have an x squared in there. So this means that we're going to have to use a chain rule because technically this is a little function inside of another function. So let's first use the chain rule and let's let u just equal x squared. And real quickly then, if I was to take du, that would equal 2x dx. So now let's rewrite this. That means that y, instead of equaling the arc cosine of x squared, now equals the arc cosine of u. Well, now we could differentiate this thing pretty easily. That means that dy equals, well, what is the derivative of our cosine? It's up here, right? It's just negative 1 over the square root of 1 minus x squared. Negative 1 over the square root. So this is going to be negative 1 over the square root of 1 minus, instead of an x squared though, it's going to be u squared. And we're going to have to remember to put that du at the end. Let's make sure I did that all right. Negative 1, square root, 1 minus u squared, 1 minus x squared. So yeah, we got the derivative. Now we're just going to plug in all the parts that we know. Okay, so that means that dy equals, let's just, since this is times by du, we could just move that on top. So there's my numerator. It's just going to be negative 2x dx over the square root of 1 minus, and my u is just x squared. Okay, I could simplify this out. I could divide both sides by dx, and that gives me my traditional derivative. And yeah, I think I'm ready to just simplify this out. That means that dy over dx is going to equal negative 2x over the square root of 1 minus, and that would end up being x to the 4th. And there we go. We have our derivative. Okay, so I would encourage you to just pause the video and try all of these if you can, and then come back and check, but I'm going to just go ahead and start working through all of these. So now we have a function that says the arc cosecant of 5x cubed. Well, it's going to be chain rule again. So let's go ahead and again we'll just say let's let u equal 5x cubed. Therefore, if I was to differentiate this thing implicitly, it would be 15x squared dx. And then when I go to plug everything back in, I'm going to just call this y equals, I'm just going to change the g of x to y, cosecant negative 1, or arc cosecant of u. That way I could call this dy equals, let's go ahead and do the derivative. So the derivative of cosecant is negative 1 over the absolute value of u, because I'm taking the derivative of u, it's square root u squared minus 1, and then don't forget to multiply this by du. So that means when I go to plug my u back in, I could just put the du, since I'm multiplying by du, could really just go on top. So it's going to be negative, and my du is actually 15x squared dx over 5x cubed absolute value square root and my u again is 5x cubed. So 5x cubed is squared, and I'm just going to go ahead and square it. So 5 squared is 25, and x cubed squared is x to the 6 minus 1. And there it is. Oh, I have one little last thing I could do. I could divide both sides by dx just to clean it up. And there it is, negative 15x squared over the absolute value of 5x cubed, square root of 25x to the 6 minus 1. Okay, let's go on to another one. Okay, so this one's kind of interesting because I think I'm going to have to use chain rule because I have 2x inside of the arc sine, and quotient rule. So let's set it up. Let's start off by saying that u equals 2x, and therefore du equals 2 dx. And then let's just go ahead and rewrite this, and I'm just going to change it to y. So y equals the arc sine of u over, and I could just still put x squared on the bottom. And now when I go to do the quotient rule, remember, I'm just going to write the quotient rule over here that it's that means the derivative of y is, I like to do the a, so a prime times b minus a times b prime all over b squared. So my a in this situation is this top, or actually to be this top, and my b is x squared. So let's just go ahead and plug it all in. So the derivative of the top, alright, so the derivative of sine negative 1u. So a couple things we got to remember. First, we got to just know the derivative. It's just positive 1 over the square root of 1 minus x squared. So let's start there. Positive 1 over the square root of 1 minus u squared. And then we're going to have to multiply this by du, because that's what the derivative of it would be. It would be the derivative of sine u times, I almost said plus, it's really times the derivative of what's on the inside, which is du. And then remember that's also being multiplied by the bottom, which is x squared, minus the top, because that's my a again, and we just put a u there, times the derivative of the bottom, and the derivative of the bottom is just 2x, and we should remember to put a little dx on the end there. Okay, and now that whole thing is over the bottom squared, so x squared squared is x to the 4th. Okay, now we can clean this thing up. We can just plug things back in, so let's do that. I got y prime equals, I'm just going to put the du and the x squared on top, okay, because I'm just multiplying, so I can just put it on top. So du is 2 dx, but I'm going to leave the dx at the end, you'll see, and x squared. So I'm going to write 2x squared dx. And then on the bottom, I have the square root of 1 minus, and my u is really 2x, right? And I'm squaring that u, so 2x squared is going to be 4x squared. All right. And then that's minus the arc sine of my u, which we said is 2x, times 2x dx all over x to the 4th. Okay, a couple little things we can do here. I realized I just kind of was using some bad notation here. Technically, I should have been writing dy here since I was taking derivative implicitly. So that shouldn't be y prime, should be dy. Because now I'm going to go ahead and divide everything by dx, which when I divide everything by dx, it's just like dividing the top by dx. So if I do that to both terms, that cancels out, and now it's dy over dx, so that's nice. So when I go to write this, now I could write this as y prime, because y prime equals dy over dx. Or I could write it as, since I started off with f of x, I could write it as f prime of x equals, it would be 2x squared over the square root of 1 minus 4x squared minus, and then I would move this 2x out here because it's not part of the sign, it's just being multiplied by. I just move it in the front. So that'd be 2x and the arc sine of 2x. And then maybe it'd be a little bit cleaner if we just multiplied this by the reciprocal of x to the 4th, which is just 1 over x to the 4th. And I'm sure you could distribute and maybe factor out some things and simplify a little bit more, but that's going to work for our derivative. So let's go on to the next one. Now the next one, I would recommend on this one that you get another piece of paper out because this one took up quite a bit of space for me. So let's get to it. Let's start with identifying all of our u's, because technically what we have here is a double chain rule. I have a function inside of this function inside of this function. So we're going to have a lot of substitution here. So let's start off with u equals 3x squared plus 1, and therefore du equals 6x dx. Okay, I'm going to write up above it. So that would mean that y equals the cosecant -1 of the square root of u. It's a little bit simpler, but still not simple enough because I still have a function inside of a function. So I'm also going to need to let v equal the square root of u, and therefore dv equals 1 over 2 square root u du. And that's nice because now I have y equals cosecant -1 of just v. And now we can take the derivative of that because we have the formula right up here. Right? So let's just go ahead and do it. It's -1 over the absolute value of x and then x squared minus 1. Okay. So dy then equals -1 over the absolute value of v square root v squared minus 1. Let's just double check that we did everything right. -1, -1, absolute value of v, or absolute value of x here, but now we're using v, absolute value of v, square root v squared minus 1, v squared minus 1. Okay. So now we should have everything we need to just start simplifying this, except for I should also multiply this by dv at the end, because that's how we use the chain rule. Alright, so let's go ahead and just start plugging in. Okay, so this is the same thing as -1 times dv, so let's put the dv on top. So this is just like, and the same thing here, I could put the du on top because it's just 1 times du. So this is like saying negative du over 2 square root u, because this is just -1 times whatever I have for dv. Alright, and then on the denominator, I have the absolute value of whatever v is. Well, the absolute value of v is the square root of u. And then I have the square root of v squared. Remember that v is just the square root of u. So if you square the square root of u, you just get a u. And actually, you technically get the absolute value of u. We'll just write u and then -1. Okay, on this one, before I go on to the next part, I realize that I could probably simplify this quite a bit. So I'm going to rewrite this as this fraction multiplied by the reciprocal of this fraction, because remember this is kind of like a fraction over 1, this whole thing. So let's just write that. It would equal negative du 2 times the square root of u times 1 over, and it would be the absolute value of the square root of u, but technically this is redundant because the square root is going to give us a positive value, so we don't really need these absolute value signs anymore. We could just say the square root of u times the square root of u minus 1. Well, I hope you can see what I see here. Now, if I just multiply everything on the denominator, I end up with a square root u times a square root u. So that is going to just be negative du over 2, and the square root of u times square root of u is u, but again, I know we're jumping back and forth here, but if I'm going to just write a u there, I should account for the fact that this was a positive value and this was a positive value, so there's no possible way I could get a negative value here, so I need to make sure that I put the absolute value of u there, times the square root of u minus 1, and now we're ready to go ahead and finally plug in our u values. So we get 3x squared plus 1. So negative du is negative 6x dx over 2, absolute value. My u is 3x squared plus 1. And then I'm going to say the square root, again, of 3x squared plus 1, and then minus 1. And you can see there's still some more simplification that we could do here. So I'm going to do that. First of all, I see that these could cancel out to give me a negative 3. So on the top, I would have negative 3x dx. And then in the denominator, I'm going to have absolute value of 3x squared plus 1, absolute value. And then this is just 1 minus 1. So really I just have a 3x squared underneath the square root. And I could separate that. I could just call that a square root 3, because the square root of 3 is just square root 3, and the square root of x squared is the absolute value of x. So I know it's a little crazy, but finally we could get down to our final answer here. Remember, this whole thing equaled dy, so I could divide dx now, and I finally can get that my dy over dx equals negative 3x over, and I can just write 3x squared plus 1 parentheses times x, absolute value bar, square root 3. And there's probably some other ways I could simplify it or mess with it. Maybe I could rationalize it, but that's good enough. So I hope you had fun with that one, and see you guys next time.